Hello and welcome back to Saxon Math. This is lesson 54, reducing by grouping factors equal to 1 and dividing fractions. The factors in the problem below are arranged in order from least to greatest. Notice that some factors appear in both the dividend and the divisor. 2 times 2 times 3 times 5 equals 2 times, does not equal, is divided by 2 times 2 times 3. So this would be the same as if we had 2 times 2, that's 4, 12, 12 times 5 would be 60, 60 divided by 12. So this problem is 60 divided by 12. 60 is the same as 2 times 2 times 3 times 5. That's the factors of 60. These are the prime factors of 12, 2 times 2 times 3. If you were to break those down in using a factor tree, and let's say we wanted to use prime number there, here's another prime number. This one would be broken down into 3 and 5. So here's the prime numbers 2, 2, 3, and 5. If you had 12, prime numbers would be 3 and 2 and 2. So you can see 3 times 4 is 12. 4 can be broken down into 2 times 2. These are all prime numbers. So these are the prime factors of both the dividend and the divisor. So if we took 60 divided by 12, you could find the answer to that pretty easily, but you could break it down into factors and do it even easier. Since 2 divided by 2 equals 1, and 3 divided by 3 also equals 1, we can mark the combinations of factors equal to 1 in this problem. So, for example, 2 over 2 is 1, 2 over 2 is 1, and 3 over 3 is 1. Because of that, it's simply, now you've got this problem, 1 times 1 times 1 times 5, which is 5. So when you look at this, you can see that if you were to divide 60 divided by 12, you'd have to guess and check a little bit here. If you did 5 times 12 would actually be 60. There'd be nothing left over. You can see this more clearly, a lot quicker than if you were to look at 60 divided by 12. But that's reducing by grouping factors equal to 1. So for this example, if we have 2 times 2 times 2 times 5, that's the same as, looks like 2 times 2 times 2 would be 8 times 5 would be 40. 40 divided by, this would be 2 times 2 would be 4, 12, and this would be 60 in the denominator. So it says reduce this fraction. So you could either look at it like this is not reduced obviously, or like this. I'm going to look at this as 1, this is 1, and this is 1. So now all I have left is 1 times 1 times 2 over 3 times 1. What does that equal? 2 over 3. The reduced fraction of all of this, using these prime factors, is 2 over 3. That's the same as 4 over 6. If we were to reduce 40 over 60 and divide them both by 10, we'd get 4 over 6. Then we could divide both of those by 2. And if you divided both of those by 2, you'd get 2 over 3. So you can see it still gets to the same answer if you were to multiply those. But the point is of this lesson is to just reduce by grouping factors that are equal to 1. So here's factors in the numerator and the denominator. That's what has to happen. So if I've got 1 in the numerator up here and 1 in the denominator down here, that means the same as 2 over 2, which is the same as 1. This one was 2 over 2, which was the same as 1. This was 5 over 5, which is also the same as 1. So you're grouping factors equal to 1. Okay, let's look at some more information here on dividing fractions. When we divide 10 by 5, we're answering the question, how many 5s are in 10? When we divide 3/4 by 1/2, we were answering the same type of question. In this case, the question is, how many halves are in 3/4? Well, it's easy to see how many 5s are in 10. It's not as easy to see how many 1/2s are in 3/4. We remember from lesson 50 that when the divisor is a fraction, we take 2 steps to find the answer. We first find how many of the divisors are in 1. This is the reciprocal of the divisor. When we use the reciprocal to answer the original problem, then we use it to answer the original division problem by multiplying. So how many halves are in 3/4? That's the same as 3/4 divided by 1/2. I'm going to just, this is, when I look at dividing by fractions, this is the first thing I think of. I've got 3/4 and I have to convert that into multiply by the reciprocal. So that's 3/4 times 2/1 is the same problem I'm going to end up with as far as the answer is concerned. That's 6/4. This would be reduced. Both of those are divisible by 2. This would be 3/2 or 1 and 1/2. So before we show the two-step process, we'll solve the problem with our fraction manipulatives here. This was my two-step problem. I like to use that first. That's the easiest, to be honest with you. The question can be stated this way, though. How many halves are needed to make 3/4? To see that the answer is more than 1 but less than 2, if we take 1/2 and cut the other half into 2 equal parts, then we can find then we can take 1 and cut another into 2 equal parts. We can fit the first half and one of the smaller parts together to make 3/4. So we see that 1.5 of the half pieces is what it took to make 3/4. So if you were to use arithmetic, the original problem asks how many halves are in 3/4. Well, you've got 3/4 divided by 2. You just have to recognize that the first step is to find the number of halves in 1. So 1 divided by 1/2 is 2. So the number of halves in 1 is 2, which is the reciprocal of 1/2. So the number of halves in 3/4 should be 3/4 of 2. And we find that 3/4 of 2, which is what we did right here, 3/4 of 2 ends up being 6/4, which also equals 1.5. So you can see that in this case there was 2/4 and then 3/4. You've got 3/4 and you're trying to divide that into half. It says how many halves are in 3/4? Well, there's one whole half. All right, this is considered one whole half. It's the entirety of a half. It's the entirety of a half. That's one whole half. This is just a half of a half. So that even though we know it as 1/4, we know that it's half of a half. So it's one whole half. So plus that other half of a half, which actually ends up being 1.5 like we had here. If that's not confusing enough. Just remember that if you're taking 3/4 divided by 1/2, this needs to be changed into 3/4 times the reciprocal. This is the easiest thing to remember. You just have to convert this into times the reciprocal every time you work out these kinds of problems. So how many halves are in 3/4? So if you have 3/4 divided by 1/2, again, that is 3/4 times the reciprocal. Okay. All right, let's look at example 3. Divide 1/2 by 3/4. So example 3, 1/2 divided by 3/4, you would recognize that 1/2 times 4/3. Okay, so you're just multiplying is what you have to do. You have to change that to multiply by the reciprocal. So now I just have the numerators times the numerators and the denominators times the denominators, and I'd end up with 4/6, and that reduces because both of those are divisible by 2. This would be reduced to 2/3. So 1/2 divided by 3/4 is 2/3. Looking at fraction manipulatives, you can see that 3/4 says what fraction of 3/4 is needed to make 1/2. The answer is less than 1. We need to cut off part of 3/4 to make 1/2. If we cut off one of the 3 parts of the 3/4, we see that 2 of the 3 parts equals 1/2. So 2/3 of 3/4 is needed to make 1/2. Now we'll show it in arithmetic, and I just did that up there. So that's the same thing. So how many, if you're just going to use arithmetic, how many 3/4 are in 1/2? It's 1/2 divided by 3/4, and you just have to convert that into 1/2 times the reciprocal. So convert it to 1/2 times the reciprocal. That's the best thing to do, and then you end up with 4/6, and that reduces to 2/3. All right, let's try this one. Letter A, reducing by grouping factors equal to 1. Do letter A for us now. So if I'm going to do this, I see that these cancel each other out. This would be 1, 1, and 1. And 1 times 1 times 1 times 3 equals 3. The answer would be 3. Why is it 3? Because this would be the same as 3 over 1. I can look at it like this. It'd be 1 times 1 times 3 times 1 in the numerators. And then it'd be 1 times 1 times 1 in the denominator. And that equals 3 in the numerator and 1 in the denominator, and that reduces to 3 because 3 divided by 1 is 3. Go ahead and do letter B. On this one, you've got 1 here, 1 here. This would be 1 here. This one is 1 here. The answer is going to be 3/5. Final answer. This would be the same as 1 times 1 times 1 times 3 times 1 in the numerator. And this would be 1 times 1 times 1 times 5 times 1 in the denominator. And you'd end up with 3 in the numerator, 5 in the denominator, 3/5. All right, how many 3/8 are in 1/2? So go ahead and do that. So for this one, I need to change 1/2 into multiplying by the reciprocal. So the reciprocal of 3/8 is 8/3. The 1/2 stays the same. That stays 1/2. We don't flip that. We do need to change that division into multiplication, and then we do change this to reciprocal. And now I end up with 8 in the numerator and 6 in the denominator. That would be the same as 1 and 2/6, and that would be reduced to 1 and 1/3. So my final answer should have been 1 and 1/3. An acceptable answer, I guess, if you didn't change it into a mixed number. Both of these are divisible by 2, so that would be 4/3. Letter D, how many 1/2s are in 3/8? So for this one, I need to change 3/8 stays the same. I need to change that to multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1. And I'm going to actually recognize that this would be 6/8. I could reduce this. I could say 2 divided by 2 is 1, 8 divided by 2 is 4. And I know that right off the bat, that's 3 times 1, and 4 times 1, that'd be 3/4. Or I could recognize here that 6 divided by 2 is 3, 8 divided by 2 is 4. The answer would be 3/4. All right. Thanks for watching. If you have any questions about anything, make sure you review the video or reread the lesson, and we'll see you next time.